Algebra 2. Today we're going to discuss Chapter 11.5, which is making inferences from sample surveys. Alright, we're going to look at our vocab kind of as we go along. So our first vocab word for today is descriptive statistics. And this is the kind of statistics you've actually dealt with before. It's the organization, summarization, and display of data. So anytime that you've seen like mean, median, mode, range, standard deviation, any kind of box and whisker, pie chart, any of that, that is descriptive statistics. It is describing that data that you collected. So looking at our extra practice, we have the number of minutes spent each day on a social networking website by a random sample of people between the ages of 18 and 64, and they're shown. And we want to estimate the population mean, which they're calling mu. So to find the mean, we're just going to add them all up and divide by how many we have. Now, it does say estimate because if by chance it's maybe like a fraction or a decimal or something, in some instances you can't have that. In the case of minutes, though, yes, we can have part of a minute. So grab your calculator and start adding these numbers together. So to find the mean, I added up all these numbers, and I got the total to be 5,431, and I divided that by 30, because there was 30 numbers there, which gives me 181.0. And then that's going to be our mean. So we're going to use mu here, or you could always use x bar. It does say estimate, but this is the actual mean, and so we're just going to leave it just like that. If by chance it was something about the number of people who did something and you got a decimal, you would want to round that accordingly. So moving on to number 2, use the data from exercise 1, estimate the population proportion, which we're going to use, that's the Greek symbol rho, in case you didn't know what that was. That's not a P actually, that's a rho, of social network users between the ages of 18 and 64 who spend more than 120 minutes each day on a social networking site. So we want to estimate the population proportion who uses more than 120 minutes. Now what we're doing is we are taking our sample here and projecting it to the whole population. So looking at our sample, I'm going to go through and I'm going to find how many have more than 120 minutes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So it looks like 23 out of our 30 are going to use more than 120 minutes, and as a decimal, that's going to be 0.77 or 0.76 repeating. So then moving on to B, estimate the population proportion rho of social network users between the ages of 18 and 64 who spend fewer than 60 minutes. Okay, so if I go and I find those who spend fewer than 60, we're looking at 1, 2, 3. Now the question is, does 60 count as fewer than 60? I don't think it does. All right, so we're looking at 3 out of 30, and 3 over 30 should be 0.1. Okay, and this is descriptive statistics here because we're looking at a number that's going to describe something. Up next, we're going to talk about inferential statistics, which uses a sample to draw conclusions about a population. So kind of what we were just doing there, but we're going to draw conclusions about the larger population. So we're going to look at extra practice number 3, and we have 2 candidates, A and B, are running for the student council president position. The table shows the results from 4 surveys of randomly selected students in the school. The students are asked whether they will vote for candidate A, and the results are in the table. Okay, so one survey had 10 people, 6 said they'd vote for A, which is 60%. Another survey had 20 people, 11 said they'd vote for A, which is 55%, and so forth. Based on the results from the first 2 surveys, do you think candidate A will win the election? So looking just at this data, do you think candidate A will win? Well, it sure looks like it. And why does it look like it? Because more than 50% of the people voted for A. Right? If the option is you vote for A or B, and you're looking at more than 50% are going to vote for A, then fewer than 50% have to vote for B, so we're good. Now, what about based on the results in the table, do you think candidate A will win the election? So based on all of them, do we think candidate A will win? We're going to go with no on this one, and here's why. The larger your sample, the more accurate your data. Okay, so as our sample got larger, the number of votes for A actually decreased. So do we think A will win? No, because the larger the sample, the fewer the votes. So this is like anything, or if I go ask one person, are you going to vote for A or B? I have that data, but the more people, if I ask 10 people or 20 people versus 50, 100, 200, 400, the larger my sample, the more accurate my data is. And so that's what we're seeing there for B. The last thing we're going to talk about today is margin of error. And so sometimes when you see a number given out like in the news or in the newspaper, they will say that, like they're a 30% chance of this thing happening, give or take 5% or whatever. So that give or take is called your margin of error. To find the margin of error, we're going to take 1 over the square root of n, and n is your sample size. Okay, and we do a plus or minus because you can be over or under what you're projecting. So if you are projecting like a certain population, P, so it would be P minus 1 over the square root of n, and P plus 1 over the square root of n would be the range of possibilities that you would expect something to fall within. So finding the margin of error is just pretty easy. You do exactly what that formula just said. You're going to do plus or minus 1 over the square root of n. So in a survey of 2,680 people in the U.S., 60% said that their data is somewhat healthy. What's the margin of error? So if we're saying 60%, but it could be plus or minus what? So plus or minus 1 over the square root of 2680. And if I put that into my calculator, 1 divided by square root of 2680, I'm going to get plus or minus 0.0193. Now that is in decimal form. So if I change that to percent to match this percent, I'm going to multiply by 100. So we're looking at plus or minus 1.93%. So that could be 61.93% or like 58.07%. Somewhere around in between that is who said their data is healthy. So what I just gave you was the answer for B, give the interval. So we would do 60 minus 1.983. I don't know where the 8 came from. Let's do 60 minus 1.93, which is going to be 58.07. Let me make sure there. Yep. Up to, so let's say between, and these are percents we're looking at. So over here we're going to do 60 plus 1.93, which is going to be 61.93%. That is your interval. All right, let me know if you have any questions. Have a good day.